Cost minimization. So we have looked at the production theory in the earlier recordings. Now let us look at cost minimization. So let us say we have two inputs, x1, x2, right? And the input prices are W1, W2. These are the input prices, right? So I need to minimize what? What is the cost of using x1? W1, x1. What is the cost of using x2? W2, x2. So I need to minimize this. This is what my objective function is. And I want to minimize this so that I can produce a given level of output, right? Subject to fx1, x2, not fxy, is equal to y or y bar, whatever you want to say. Hmm. So the what is cost minimization exercise is that in order to achieve a given level of output, what is the minimum cost? And this is going to be the function of the input prices and the output. This is going to be the function of the input prices and the output, the minimum cost of achieving a desired level of output depends upon input prices and output, right? So the way I'm going to write my cost function is this way. It is the function of input prices and output. It is the function of input prices and output. So what it is measuring the minimal cost of producing a given level of output at a given price, at the given input price, right? So it measures the minimal cost of producing y units of output when factor prices are W1, W2. When factor prices are W1, W2, right? So you have an isoquant here. Okay, I'll also draw an iso cost curve and I'll tell you what that would mean. So you have input x1 here, you have input x2 here, right? So let me draw an iso cost line. So all points on this line is going to cost same. What is an iso cost line? That means all combination of inputs that have the same given level of cost, right? So all combinations of inputs that have the same given level of costs, that have the same given level of cost. So for example, you write C is equal to W1 X1 plus W2 X2. So this is an ISO cost line, not a cost function. So W1 and W2 are given to you. This C is also given to you, that they should be costing, I mean, this use of X1 and X2 should be costing this C, right? So there could be different values of X1 and X2. Maybe you can just use X1 or you can just use X2, whatever. You can use it whichever way. So I can write it like W2 X2 is equal to C minus W1 X1, or can write X2 as C upon W2 minus W1 by W2 X1. C upon W2 minus W1 by W2 X1. So if you want to draw this line, it's going to be like this. Beta, when X1 is 0, then X2 is C upon W2, this point. When X2 is 0, then C is equal to W1 by X1. So X1 is what? C by W1, this point. So also you can look at it from this y is equal to mx plus c form. This the slope of this line is W1 by W2. The slope of, you can also write the slope of this isocost line is what? C upon W2 whole upon C upon W1. That would mean C upon W2 into W1 by C, that is W1 by W2. So the slope is W1 by W2. I mean, you put the minus sign, of course, this is a negative slope. So every point on this isocost line, the cost is same. Every point on the isocost line, the cost is same. 1 point. Every point on isocost curve has the same cost. Has the same cost C, right? Acha, if you go to the higher isocost line, for example, like this, with a different C dash. Now, C dash is greater than C here. So a higher isocost will be showing you the higher cost, right? The higher isocost lines are associated with higher cost. Are associated with higher costs, right? So, Acha, now you have the isoquant like this. Tuk, 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 something like this. So this is an isoquant. Hmm, hmm. Now, what is an idea? The idea is that you need to find out a point on the isoquant which is going to touch the lowest possible isocost curve, right? At that point, you will be producing. So, beta, if I want to produce this, this is, I mean, all the points on this isoquant can tell me that this is the output which I'm going to produce. So that is drawn for a given level of output. Now I can produce the same level of output, let's say y, with the higher cost also. But why I should be producing it with a higher cost? I can produce the same level of output with a lower cost also. So here, to produce the same Y, it is costing me more. You may not want to write this, I'm just making you understand. To produce same Y, it is costing more. Hmm? Here, to produce same Y, it is costing less. Hmm? So what should be the idea? The idea should be that we should be able to find out a point on the isoquant which is going to touch the lowest possible isocost curve. That's an idea. Is right. So find the point on the isoquant that has the lowest possible isocost line associated with it, right? Associated with it. This is the point of tangency. So it is the point of tangency between the isoquant and the isocost. This point. है ना? This is the point of tangency between the isoquant and isocost line. It is the point of tangency between the isoquant and the isocost line. So at tangency, hmm, that optimal point, at the point of tangency, not optimal points, it is just a point. So at the point of tangency, what happens is that your the slope of an isoquant is equal to the slope of isocost. Hmm? Slope of isoquant is what? MRTS. Slope of isocost is what? You have just seen beta, W1 by W2. You know, we're taking it up in the absolute values, right? So you can also write it like MRTS, which is a function of x1 star, x2 star. And this is nothing but MP1, which is the function of x1 star, x2 star upon MP2, which is the function of x1 star, x2 star. Mhm. Which is the function of x1 star, x2 star. Now, what is x1 star, x2 star? You just know this, I'm sure. Tuck, tuck, tuck. This is what your x1 star is. This is what your x2 star is. That is the optimal employment of the inputs. This is what the optimal employment of the inputs. है ना बेटा? अच्छा. Then you have a point like this. So you have y equals to f of x1, x2. So delta y is equal to what? Guys, you tell me one thing. When you have the function like this, how do you write the total differential? Just a simple mathematical economics rule. So you write it like this now. dy equals to del f by del x1 into dx1 plus del f by del x2 into dx2. This is the way you write it. So I can also write total differential here like this only. This you must have done in our earlier recordings as well. So you write f1, f1 is your del f by del x1, which is the function of x1, x2, into dx1, which I'm writing as delta x1, plus f2, which is del f by del x2, is the function of x1 and x2, into dx2, which I'm writing as delta x2. But along an isoquant, delta y is equal to 0. So 0 is equal to f1 Mhm. Along an isoquant, output doesn't change, na? So I can assume delta y to be 0. Output is constant. So those are the different combinations of the inputs which is going to give you the same level of output. So I can write f1 as mp1 or mpx1, right? mp1 only, plus mp2, like this, right? So when when can this hold, right? So delta x1 and delta x2 should have the opposite signs. Of course, your MPs are positive beta. So if you're not, if your marginal product is not positive, why on this earth you will employ this input? Uh, so I mean, whenever you're employing any, these x1 and x2 are nothing but your inputs. So if you're employing any inputs, those marginal products have to be positive. So the only thing is that if MP1 and MP2 are positive, and this thing has to come out to be equal to 0, so delta x1 and delta x2 will should have the opposite signs. Note that. Delta x1 and delta x2 must be of the opposite signs, right? Must be of the opposite sign, right? So just think about it this way. If we are at the minimum cost, one thing. So let me just call this expression as 1. Let me just call this expression as 1. Now, if you are at the minimum cost already, then whatever change is going to happen, this cannot reduce the cost. So you're already sitting here at this particular point. Now there is no point of changing. If you change anything, this will not reduce the cost. So for example, if you move, let's say till here, then it will lead to I don't want to draw this, but just want to make out a point. That is the reason I'm just drawing. So the line which is going to pass through this point is going to be this. Now this is a higher isocost line, no? This is a higher isocost line. So I mean, when you're already at the minimum point, so this change cannot lower the cost. Please write this. If we are at the minimum cost, then this change can't lower the cost. Then this change, it cannot lower the cost. So you have what? W1 delta x1 plus W2 delta x2 is greater than equal to 0. That is, it cannot lower the cost, right? It cannot go below than this, right? Uh, so now let's consider a change. Suppose there is going to be the change. Uh, now, now suppose we consider the change. Now consider this change. Let's say minus delta x1 minus delta x2. So I'll give you a very easy way of going about this. Varian has done this uh, in a little complicated way, I guess. Let's say this level of output is also producing the same level. Sorry, this is also producing the same level of output. This also produces the same level of output, right? Not outputs, it is output. Hmm. And it also cannot lower the cost. And it also can't lower the costs. Hmm. So it means what? It means minus, because in place of delta x1 you have minus delta x1 minus delta x2 greater than equal to 0. And if you take the minus sign here, this will become negative. So if you consider 2 and 3 together, consider 2 and 3 together. So this is going to give you equal to 0, right? Together they'll be true at W1 delta x1 plus W2 delta x2 together. So from here, your delta x1 by delta x2 is equal to what? Minus W1 by W2. From here, delta x1 by delta x2 is what? Minus mp1 by mp2. So putting both of them together would mean what? Would mean this, that delta x2 by delta x1 is equal to minus W1 by W2 is equal to minus MP1 by MP2. Both this minus minus will get cancelled out. So this is the condition of the cost minimization. This is the same condition, beta. Uh, that's the same condition at the point of tangency. The same thing. So this is the condition of cost minimization. This guy is the condition of the cost minimization. Uh, so, and whatever input choices which you are going to get from this thing, your x1 star and x2 star, they will also be dependent upon the input prices and the output, right? The choice of input. So I've not given you any numerical example, Abhi, but once you will solve this, you will be getting the input choices. So once you solve this condition, you'll be getting the input choices, optimal input choices. And they are the function of input prices and the output. They are the function of input prices and the output, right? So what do they measure? And they are called the conditional factor demand function. They are called the conditional factor demand function. So if you remember, um, I don't remember here, but we have given you an idea how to, for example, uh, here in these cases. Uh, so what you get from the profit maximization exercise, you will be getting as the your unconditional factor demand functions. Okay, I still have to do profit max with you. I thought I have done that. Okay, so conditional factor demand functions. So these are conditional. Conditional upon what? So they measure the relationship. Please write. I've done production with you. I thought I've done profit maximization also. They measure the relationship between the prices, right? Between the prices and the output. The prices and the output. And the optimal choice, of the form, optimal factor choice, you can write. Optimal factor choice of the firm, right? This is telling you this is conditional. Why do you use the word condition? It is conditional on the firm producing a given level of output. Producing a given level of output Y. It is conditional on that. So the condition is that you have to produce a given level of output Y. Now, what input choices you should have, how much you should be employing of labor and capital. That's an idea. So we'll do few examples tomorrow. I think then you will understand it more. हाँ, चलिए, thank you बेटा.